looking at number 4, first of all, this is on page 84. This is a very important concept to understand. So number 4 says, let the graph of G be a horizontal shrink by a factor of 2/3. So the first thing we have is a horizontal shrink of 2/3. The next thing we have is 5 units left. And then the last thing we have happening is 2 units down. And our original function is f of x equals x squared. Now, we have done this kind of problem before, but we haven't gone as in-depth as this one does, because this one has every transformation possible except for reflecting happening, and it's also a matter of doing things one at a time and in the order at which they occur. So if I'm going to change this into a g function, the first thing I want to do is I want to look at the fact that this is a horizontal shrink. When we have a horizontal change of anything, it's the opposite of what we would think. So we would think we would use 2/3, but what do we really use? Charlie? 3/2. So what has to happen is, wherever we have an x, we have to replace that x with a 3/2 x. So our x in our original function has to get replaced with a 3/2 x. The next thing that has to happen is we have to go 5 units left. So now we have to look at our function, and whatever function we have to replace this x with something that would shift it 5 units to the left. Again, this is dealing with the horizontal. So if we're dealing with the horizontal, it's going to be the opposite of what we would think. So Michaela, what are we going to do? Is it going to be x minus 5 or x plus 5, our replacement for the x? It's going to be x plus 5. So instead of using x, we're going to have to use x plus 5. So now we can see that that whole thing has to be inside the big parentheses and getting squared. Then the last thing that happens, so we have everything like this for now, and the last thing that happens is that we have to go 2 units down. Sydney, how do we make it go 2 units down? The whole thing has to get subtracted by 2. So this is a great answer. This is going to be a horizontal shrink of 2/3. Then it's going to be shifted 5 units left, and then it's going to go down 2. But let me show you the answer that they have in the back of the book as another option. This is what they have back there. Can you see why that would really be equivalent? But it might not be something that you would really recognize at first, right? But we can see that it's really equivalent to this. Now, if I were you, I would always just stick with this. Because when I look at that answer, I can immediately see that this 3/2 is inside the parentheses. But what this is also saying is that for a quadratic, so for quadratics, a horizontal shrink of 2/3 is equal to a vertical stretch of 9/4. Now that's only going to be true for quadratics. It's not going to be true for absolute values, because in that case, the x wouldn't be getting squared. That horizontal movement, or what we would say shrink in this case, is not going to be getting squared for an absolute value. But for quadratics, that's actually a true thing there. Okay? So if I graph this into my calculator and this, they're going to be exactly the same thing. So that's number 4. So think of it as replacing x. That's the best way to do it. We've always been saying the whole time, like, put it in front of x or do it to the x. I think it's easier if you just think of replacing the x. So replacing the x with the 3/2 x. Replacing this x now with the x plus 5. And then at the very end, putting the -2. All right, now let's take a look at number 9. This one is also pretty challenging. So this is number 9 on page 85. So this question says, you make a solar hot dog cooker. Okay, so something for you to do this weekend, right? By shaping foil-lined cardboard into a parabolic trough and passing a wire through the focus at each end piece. For the trough shown, how far from the bottom should the wire be placed? Okay, so you can see the picture in your book. So basically, we're just trying to find where is the focus. That's our goal. Where should that wire go in order to create this solar hot dog cooker? So we're going to draw a picture of this parabola. We're just looking at a cross section of it. Now, they tell us that it's 12 across. If I call this vertex right here 0, 0, and it's all the way across as 12, could I then know a point on my graph? Baxter, what would be this point if it's 12 across and 4 deep? What would be this point right here then?
It would be 6 and then 4.
Right. It would be 6, 4, wouldn't it? So the question they're trying to have us find is, where is this focus? That's our question. Where is that focus? In order to find the focus, we have to know P. We have to know where P is to be able to find the focus. So to find P, we have to know the equation, right? So this is more than just one simple step. This is going to take us a couple of steps. So I'm going to use my formula then. Y equals 1 over 4P, and then x minus h squared plus k. I'm going to have to use that formula so that I can figure out what P is. Well, here's my xy, here's the hk at the vertex, so now I can just substitute in. Y is 4, 1 over 4p, I don't know that. H is 0, so x minus 0 is just x squared, and k is 0. Oops, I forgot to plug in. Do I know x? I do, don't I? So now I'm going to have 4 equals 1 over 4p, and then I do know that x is 6, and I have to square it. So if I can solve this equation, I can figure out what p is. So what is 6 squared? That's going to be 36, right? So we're going to have, I'm going to come over here, I'm running out of room. I'm going to have 4 equals 36 over 4p. What does that simplify to if I have 46 over 4p, 36 over 4p? Well, let's just cross multiply. Let's do it this way. Yeah, you could simplify it down to 9. We can also just cross multiply here to find p. So I have 16 equals 16p equals 36. And so p then is going to be 36 over 16. And then that reduces down to what? 9/4. So the p value has to be 9/4. So this question was asking us, how far up does this wire need to go for it to be at the focus? Well, the distance between the vertex and the focus is p, so therefore it's going to have to go up 9/4, which is what, 2.25 units? going to have to go up 2.25 units for torque. Any questions on that? Do you feel like you could have gotten through that on your own if you had to, if you had enough time to think about it? I think you could. It's tough, but you could do it. Any questions over that problem? Let's talk back through one more time what we did. So we put the vertex was at 0, 0. Here's our point at 6, 4. Did you understand how we got the point? Okay, and we then just wrote out our formula, which was y equals 1 over 4p. We substituted in for y, for x, for h, and for k. And because we substituted in for all of that, which I forgot to do the x, so I had to come over here and do it. But then we were able to cross multiply and solve for p, and then we could figure it out. Okay? Questions? All right. So take the rest of the time.